Hello students, as we are already familiar with what are acids and what are bases, just to recapitulate quickly, acids are those substances which are sour in taste and they turn blue litmus red, right? And what about bases? Bases are those substances which are bitter in taste and have soapy touch. Yes, and not only that, they also turn red litmus blue. So we are already aware about these concepts. So let's proceed further with the next chemical property, and the property here is, what do all acids and bases have in common? Right. So what do you think? What do they have in common? Which ions all acids and bases release? Do they release any ion? Yes, they release ions only in the presence of water. Yes children, water is really very important for the dissociation or breaking of any substance into ions. So acids and bases, they release ions only in presence of water. So all acids, they generate hydrogen gas on reacting with metals, that you have already understood. So all the acids release hydrogen ions in water. How? Let's take an example. So suppose I have HCl as an acid, and if you put it in water, what will happen? HCl will ionize in water, and what is the meaning of ionize? It converts into ions. So HCl will ionize into its ions and form H plus and Cl minus. So this H plus will actually combine with H2O to form H3O plus Cl minus is remaining. So this H3O plus is also known as hydronium ion. So what do we call it? Hydronium ion. So it means we can say that when you keep acids in water, they release hydrogen ions or hydronium ions in water, right? Then what about bases? All bases release hydroxide ions in water. So for example, you have NaOH. What is the property of NaOH in water? NaOH, when you keep it in water, it dissociates or breaks into its ions. So it is forming two ions, cation and anion, Na plus cation and OH minus anion. So this OH minus ion is hydroxide ion, right? So what do acids and bases common in them? They release free ions in water. So children, let's look at the activity to understand whether the given substances are good conductors or bad conductors. Because if acids and bases are good conductors, it means they must have free ions when dissolved in water, right? So what is the activity saying? All compounds containing hydrogen are acids and are good electrolytes in their aqueous solution. So we will be proving by this activity that all the acids, they release hydrogen ions in water and they are good electrolytes, means they are good conductors of electricity, right? So let's look at the activity. Let's see the animated video first to go into the details.
Prepare solutions of hydrochloric acid, sulfuric acid, alcohol and glucose by dissolving them in 50 ml of distilled water in separate beakers. Fix two brightly polished nails in a rubber cork and place it in 250 ml beaker. Connect the nails to a 6-volt battery, a bulb and a switch. Pour hydrochloric acid solution in the beaker and switch on the electric current. Notice that the bulb glows brightly on switching on the current. Switch off the circuit. Pour off hydrochloric acid. Wash the beaker and the cork with distilled water and again set up the apparatus. Repeat the experiment for dilute sulfuric acid, alcohol solution and the glucose solution. You observe that the bulb glows brightly in case of hydrochloric acid and sulfuric acid solutions. Bulb does not glow in case of alcohol and glucose solutions. From the above observations, it is clear that all compounds containing hydrogen as its constituent cannot be acids. Then, what makes a substance an acid? Glowing of electric bulb suggests that there is a flow of electric current in acid solutions. Now, the electric current in a solution can be carried by the ions. The cation present in acids is H-positive ion. This implies that the acids on dissolving in water produce hydrogen ions H-positive aqueous. It is the hydrogen ions H-positive aqueous which are responsible for acidic properties. Repeat the same activity with the following soluble bases alkali solutions: sodium hydroxide NaOH, potassium hydroxide KOH, lime water CaOH2 and magnesium hydroxide MgOH2. You observe that bulb glows in each case. Now, glowing of electric bulb suggests that there is flow of electric current in alkaline solutions. As we know that the electric current in a solution can be carried by ions. The common anion present in all alkalis is hydroxyl ion OH negative aqueous. It is the hydroxyl ion OH negative aqueous which are responsible for alkaline properties.
So this picture explains that we have a beaker where we have kept a rubber cork and in which iron nails are fitted. See, 2 iron nails are fitted. Instead of anode cathode strips we have put iron nail. But yes, you can take anode and cathode. There is no need to take nails. You can take you can take cathode or anode instead of iron nails, because we are just have to prove that the electrolyte or the substance that we have taken in the beaker, it is a good electrolyte or a bad electrolyte, right? So now what about the electrolyte here? So we are taking dilute HCl solution because I want to prove that any acid is a good conductor in its aqueous solution. So that's why we are taking dilute HCl solution. Dilute means we have added it in water, right? Then we have connected it with battery, 6-volt battery, and there is a bulb and switch attached, right? So we will see whether the bulb will glow or not. So when we have done this activity, it was found that when we taking HCl here, then this bulb actually glows, right? It means, is HCl a good conductor or bad conductor, children? Yes, HCl is a good conductor of electricity because as soon as we switch on the key, bulb glows. Why bulb glows? Because the current passes through the HCl and HCl is a good conductor and therefore it conducts electricity and bulb glows. But why HCl is a good conductor? Because HCl, what could be the reaction for HCl in water? As we already wrote that HCl plus water, it will form Cl minus ion, and which ions? H3O plus. So because it releases H3O plus ions, therefore it is a good conductor of electricity. It has free ions in its aqueous solution to conduct electricity, right? So let's understand the observations here. The first observation is the bulb will start glowing in the case of acids. This indicates that there is a flow of electric current, right? There is a flow of electric current through the solution. Why? Due to the presence of free ions. And what are the free ions here? H plus ions as cation and chloride ion as counter ion. H plus ion, or we can say hydronium ion also, right, in their aqueous solution. Now, in the same activity, if instead of taking HCl, if we take the solution of alcohol or we take the solution of glucose, what do you think, what could be the observation? So when the same activity was performed with alcohol or glucose, this bulb didn't glow. Yes, the bulb doesn't glow here. Why bulb doesn't glow? Because it means that alcohol or glucose is a bad conductor of electricity. But why they are bad electrolytes or a poor conductor of electricity? Because they don't contain free ions. So can we say that they don't release H plus ions in water? Yes, they do not release H plus ions in water. Hence, the next observation says glucose and alcohol solutions do not conduct electricity due to the absence of free ions. So, can we say glucose and alcohols are acids or not? No, they are not acids. They do not release any ion when dissolved in water. So, they do not release H plus ions as well. So, now the third observation here is acids produce hydrogen ions or H plus aqueous in solution, which are responsible for the acidic properties of HCl. Do you agree with this? Yes, because again let's write the reaction. As you know that HCl, when you dissolve it in water, it releases hydronium ion and chloride ion, right? So, because it releases hydronium ion, this hydronium ions are responsible for acidic properties of HCl. Similarly, if you take any other acid, let's take HNO3. What will happen with nitric acid? When you will dissolve it in water, what will happen, children? HNO3 will release its H plus towards water to form hydronium ion. Plus counter ion is nitrate ion here. So, this hydronium ion actually decides the acidic property of nitric acid only when dissolved in water. This water is really important. In absence of water, acid does not show its acidic property. Yes, please remember this very carefully, that all acids, they only release H plus ions in water, means they show acidic properties only in the presence of water. In absence of water, they are not acidic. They do not show acidic properties. They do not give any indicator test. Okay. Now, similarly, the way we talked about acids, what about bases? Bases or alkalis such as sodium hydroxide, calcium hydroxide, etc., they also conduct electricity. It means when you performed this activity with a base, the aqueous solution of base, means it should also be dissolved in water, then this bulb will glow, right? So, bases are also good electrolytes. Why they are good electrolytes? Why they are good conductors of electricity, students? Because they release hydroxide ions in water, right? So, because of the presence of free hydroxide ions in water and countercations, they are good conductor of electricity, right? So, let's look at the example for that. Suppose I have sodium hydroxide. When you dissolve it in water, what will happen? Sodium ion and OH minus ion get separated, and these free ions are responsible for the good conduction of the aqueous solution of sodium hydroxide. Thank you.